Hey and welcome to another tutorial by cgbookcase.com. Today we're gonna be making the interactive interior scene that you see in front of you using Blender and Verge3D. If you've never heard of Verge3D before, it's a great tool that allows exporting Blender projects to a web-friendly format and adding functionality using a very easy to understand visual programming language called puzzles. This video will show you the exact process of creating an interactive 3D interior scene. We'll start by modeling, lighting and shading the scene in Blender, then optimizing it so it can be displayed in real time in a web browser, and making it interactive using Verge3D's puzzle editor and some basic JavaScript. So let's open Blender and make it happen. When modeling an interior scene, I always start with the floor. I've already created a floor plan that I'm using as an empty image when viewing the scene in orthographic view. Using a plane and some loop cuts, you can add them by pressing Ctrl R. It's very easy to model the floor. Next, we can create the walls and the ceiling by selecting all faces and then pressing E and 2.4 to extrude them by 2.4 meters. Because we want to add a different material to the floor than to the wall, it might be a good idea to separate them, which you can do by selecting the floor faces, pressing P and clicking Selection. To create the baseboard of the wall, you can select the bottom edges of the walls, duplicate them by pressing Shift D and also separate them from the wall. Then we can add some height to the baseboard by extruding the edges and add some thickness to it using the Solidify modifier. Next, we can smoothen the edges by adding a bevel modifier. To add the windows, we first need to cut the holes into the wall, which you can do by adding loop cuts and then deleting some faces. Then you can add a window by pressing Shift A and going to Mesh, Archipect, Window. I also did the same process for the door, but I did not cut a space for the door since you can't open it in the final project. Most furniture models in the scene are by Vitra, a company that makes very comfortable furniture. You can download them from their website for free. You can find 3D models of most of their products on each product's page by going to Information and then to CAD Data. Then you can download a 3ds file. Sadly, you can't import a 3ds file into Blender 2.8 yet, but you can import it in Blender 2.79 by going to File, Import, 3D Studio, then append it from there. The topology of the models is usually very bad, since they are not designed for real-time rendering, so we need to optimize them a bit. First, we want to get rid of the tris topology and convert it to quads by pressing Alt-J. There will probably be some overlapping geometry, but you can get rid of it by going to Vertex and then clicking Remove Doubles. Now we should be able to remove some loops. With Edge Select mode activated, Alt-click any edge that's part of the loop you want to remove, so the entire loop is selected. If that's not possible, the tris to cuts operation wasn't perfect and we have to do some manual cleanup, which sucks, but it's worth it. When you've selected a loop, press X and click Dissolve Edges so the loop will be deleted without leaving an empty space, or just click Ctrl X, which does exactly the same. On the more organic models, in my room this is the couch only, I also added a Decimate modifier to reduce the number of vertices the object has. You can try all three algorithms, but I usually go with collapse and decrease the ratio to a point where the model still looks decent, but also has a manageable amount of vertices. In the kitchen, I model most objects by myself. To model the cabinets, you can just use some cubes and scale them on the X, Y and Z axis. Because you can't open the drawers in the final product, I obviously did not model the interior of them. I created the countertop in the same way using a cube and a bevel modifier. To create a sink, we can add another cube Place it where we want the sink to be and add some bevel to it. To cut a hole into the countertop, select the countertop, add a boolean modifier with the operation set to difference, and use the beveled cube we've created before as the object. If you now apply the modifier and move the beveled cube out of the way, you'll see that there's a hole in the countertop. Then I use the bottom half of the beveled cube as the actual sink itself. Creating the faucet was also quite straightforward. To model it, we can start with a circle and then extrude and scale the edges to our liking. You might notice that it's quite hard to create a good looking curve by just using extrude, but there's a nice tool called Bridge Edge Loops which you can use to connect multiple loops. Go to Edges, Bridge Edge Loops and increase the number of cuts to get a smooth curve. To model the handles, we can start with a plane, add some loop cuts and extrude them, just like we did at the beginning with the floor and the walls. I've also added a bevel modifier here to bevel the edges, which helps making the 3D model look more realistic when rendered. To create the lighting, I used an environment map from HDRI Haven, a website that offers free HDRIs. Since you can't really render a realistic looking interior in real time in a web browser, we have to bake the lighting into texture maps. But before we can bake the light, we need to unwrap all objects. It would be a real pain to do that for every single object in the scene, so we're gonna join them together as one object. Now we can go to edit mode, select all faces, press U and click on Smart UV Project to automatically unwrap the entire mesh. Then I scaled down the UVs for the areas that you won't see in the final product anyway, for instance the bottom of the couch and so on. I also recommend scaling down the UVs of the ceiling, since I don't expect the user of the product to look at the ceiling very closely, so we don't need a lot of detail there. Then you can select all the UVs and go to UVs, Pack Islands to automatically tidy up the UVs. Before we can start baking, we need to create a new material that we want to bake. Select one of the objects, open the shader editor, and to be able to edit the object's material, set the shader type to object. Then we can create a new material by clicking on this button. Let's call it base material. By default, it will add a principled shader. Let's delete that and add a diffuse shader instead, because we only want to bake shadows. Next, open the image editor and create a new texture. Set the resolution to 4096 by 4096 pixels and make sure you've checked 32-bit float so we can save values greater than 1. Then click OK. In order to bake onto this texture map, we need to add this image as an image node to our base material, so the Blender knows to which texture it should bake the light. Then, to finally bake it, we can go to the Render tab, scroll down to Bake, set the Bake type to Combined, and the margin to about 4 pixels. Then hit Bake. After baking is done, you'll probably see some blown highlights. That's because by default Filmic doesn't affect textures. In order to make Filmic affect this texture, you can press N to bring up the Properties region and then activate the box next to View as Render. This way, the texture will be affected by all changes you do in the Color Management section in the Render tab of the Properties editor. Then we can export the texture by going to Image, Save As, or hitting Shift S. Set the file type to PNG and the color depth to 16 and save it wherever you want. Next, we need to denoise the texture. I use Affinity Photo to do this, but feel free to use any image editing software you want. Then, drag and drop the texture into Affinity Photo. To denoise the texture, we can click this weird icon here and choose Denoise Filter from the list. Adjust the values until you're happy with the result and then close the window. Next, open the export settings by going to File, Export. Because the browser needs to download all textures in our scene when loading it, we want the file size of the image to be as small as possible. Select JPEG as file format and set the quality to about 80, so we have a nice balance between quality and speed. Hit export and save it to your computer. Next, we're gonna set up a Verge3D scene and create the materials. To download Verge3D, head over to soft8soft.com, click Get Verge3D, select Verge3D for Blender and download it. Quick note here, Verge3D is free for evaluation purposes only. If you want to use it in a real project, you have to buy it. Unpack the zip file to a directory of your choice. Then open Blender and go to User Preferences. Go to File tab, find the Scripts field and select the directory where you unpacked Verge3D. Then save the user settings, close and restart Blender. Then go to the Add-ins tab, search for Verge3D and activate it. If you've done everything correctly, a sneak peek and the App Manager button should appear. In order to create a new Verge3D app, you need to open the App Manager by pressing this button. Then enter a clever name and press Create New App. After you've created the app, it appears in the list of projects. By clicking the blue icon next to it, you can run the full application in the browser. By clicking the green icon, you can run the 3D scene only without the user interface. By clicking on the puzzles icon, you can enter the puzzle editor. By clicking on the Blender icon, you can open the scene in Blender, and by clicking the world icon, you can publish your app on the web. So let's open the file in Blender and start working. You'll notice that there are some default objects in the scene. By clicking Sneak Peek, you can preview the scene in the browser. If you want to run the scene from the Verge3D App Manager, you first need to export it as a GLTF file. You can do this by going to File, Export, Verge3D GLTF. Then click the blue icon to see the application in the browser. Next, we want to import the scene we've created before into this blend file. We can do this by going to File, Append, navigating to your older blend file, and then selecting all objects in the object folder. Open the shader editor and replace the diffuse shader that the object currently has with an emission shader. Also, make sure the viewport shading is set to rendered so we'll get an accurate representation of what the material looks like. Next, we want to add our baked lighting to the material. Press Shift A, go to Texture, Image Texture and add an image node. Next, we're going to connect the image node to the emission node. And voila, we've created our base material. Then we're gonna separate all objects that should have a unique material. Example, I want all the chair frames to have the same material at the same time, so I'm gonna separate them from the current mesh. You could use material slots to use different materials on different parts of one object, but separating them makes programming later much easier. Speaking of making programming easier, we should probably also rename our objects using unique file names, so we won't have to deal with 20 different objects that are all named cube or plane. Next, we're gonna take care of the couch material. In order to only change the couch's material without changing every material in the scene, we need to press a small number next to the name of the material. This way, you will duplicate the current material only. Next, we can add a Mix RGB node and drop it between the image texture and the emission shader. If you set the blend type to multiply and the factor to 1, you can colorize the material with the bottom input. I want the couch to look more like actual fabric, so let's search for some free fabric textures online. I hope they'll have a few. This one looks promising. Let's just download the base color map. Since we want our application to load very fast, remember every texture in our scene has to be downloaded by the user's browser, and we're going to change the color in Blender anyway. Let's make this texture grayscale. Open your favorite image editing software, In my case, it's Affinity Photo again and import the image. To make it grayscale, we can go to Document, Color Format, Grayscale. Next, we can open the Export menu, pressing Command-Alt-Shift-S if you're on Mac or Ctrl-Alt-Shift-S if you're on Windows. Set the resolution to about 512 by 512 pixels and the quality to about 80 and export it as a JPEG. Of course, you can also choose a different resolution, but make sure it's a power of 2, otherwise Verge3D will scale the texture down. Then import the image as an image texture to Blender and mix it with the previous nodes using a Mix RGB node set to multiply again. Now you'll see that the texture is mixed with the material, but the scale is probably much too big. We can easily fix this by adding a mapping and a texture coordinate node. Connect the UV of the texture coordinate node to the mapping node, then connect the vector of the mapping node to the vector of the image node. By the way, if you have the Node Wrangler add-on enabled, you can do this in no time by selecting the image and then hitting Ctrl T. Then adjust the X and Y scale until the scale looks realistic. We might also want to add a color ramp node after the fabric texture to make the material a bit brighter. Next, we're gonna rename the material, duplicate it a bunch of times and create a few variations. That's basically the workflow for every material in the scene. To some materials, I've also added a bit of gloss using a glossy node. Most textures, for example the floor textures, are from cgbouquets.com. I also recommend searching on CCO Textures, a great site with tons of good textures. The table material, for instance, has been created with a texture of this site. Now we can start making the scene interactive. Before we can start using the puzzles, we need to export the scene as a GLTF. If you haven't done this yet, go to File, Export, Verge3D GLTF. Then open the App Manager and click the puzzles icon. Now this is the puzzles editor. There are two tabs, the Init tab and the Main tab. In the Main tab, you create scripts that affect the 3D objects in the scene, like changing the materials and so on. In the Init tab, you can create scripts that don't affect the objects in the 3D scene, like changing the loading icon. We're not gonna use the Init tab in this tutorial. It's actually quite simple to create a script using puzzles. For instance, if you want to open a web page as soon as the application is loaded, we can just use this open web page block. If we want to open the web page only when a specific object is clicked, for instance the carpet, we can add the when clicked event block, which will trigger the blocks that are inside it and add a selector to select the carpet. Then we can put the open web page block inside the event block. Now the web page only opens when we click the carpet. Obviously that's not what we want, but I hope it helps to demonstrate how the puzzles work. What we do want, however, is for the objects to display this kind of highlight or this outline that you saw in the preview when the user hovers over them. In order to do that, we can use the Outline Enable block, which you can find in the Main tab in the Objects category. Now by default, this block is grayed out, because we didn't enable the outline effect in our blend file. We can change this by going back to our blend file, then going to the Render tab in the Properties editor and scrolling down to the Verge3D settings. Here you can enable outlines and also change a few settings. I'm not going to change anything because I quite like the default style. Next, we'll need to re-export it. Go back to the Puzzles editor and reload the page so we can use the Outline Enable block. We're first gonna add the effect to one object only, the couch. Now you should be able to drag the Outline Enable block into the workspace and actually use it. We want the objects to be highlighted only when we hover over them. To do this, we need an event block. So let's add the when hovered event block, then we will select the couch using a selector block and move the Outline Enable block into the first slot of the event block. We also want the outline to be disabled when the user isn't hovering over the object anymore, so let's copy and paste the Outline Enable block down and set it to disable. Let's check if it works. And it doesn't, because after every change we need to save the scripts using this button and run the application using this button. Now it does work. Next, we want the camera to fly to an object when we click on it. To do this, we can use the tween camera block in the camera category. This block makes the camera fly to the position of an object and point to another object. The cool thing is, it doesn't have to be a mesh object, it can also be an empty object. If you've never used empty objects before, they are basically just objects without actual geometry, so the user won't see them when the scene is displayed in the browser. You can add empty objects in Blender by pressing Shift A, empty, and then choose any object you like. I want the camera to be at this place and face into this direction after the user clicks the couch, so I'm gonna add one empty object here and another one here. Next, we need to re-export the scene so we can use the empty objects in the puzzles editor. Then we can place a tween camera block into a when clicked block, save the scripts, run the application and see if it works. It does, great. Now we can repeat this process for every piece of furniture in the scene. Next, we're gonna add the user interface on top of it. I'm not gonna explain every bit of it. If you have some problems following along, you can download the finished scene after watching the video and take a closer look at it, or just ask in the comments section. Some HTML and CSS knowledge probably is required to understand this part. If you check the folder of your project, you'll see that Verge3D has created a few files for us. An HTML file, which actually is open when we press the blue button in the app manager, a JavaScript file where you can add more functionality, and a CSS file where you can style the HTML elements. The background of the application is just a div with the position set to absolute and the top set to 0. The height is set to 100%, so it covers the entire page from top to bottom, and the width is set to 25%. I've also added some padding, so the elements inside the div have some room to breathe. To separate the user interface a bit from the 3D scene, I've also added a box shadow with some blur. The most important attribute though is the C-index, which I've set to 1. The C-index basically defines when an element is rendered. The greater the C-index, the later the element is rendered. The 3D scene has a C-index of 0, so if you set the C-index of the user interface to anything greater than 0, it will be displayed on top of the 3D scene, which is what we want. The categories are just some headers that change the cursor to a pointer when hovering over them. The elements where you can change the material are just a div with the display set to grid, the name as the first element, and 2 SVGs as the second and the third elements. Now to make these buttons work, we need to use some JavaScript. Because we need the buttons of the interface to communicate with the objects in the 3D scene, it is not possible to do this with the puzzles editor only. If you open the JS file, which was automatically generated when creating the project through the app manager, you'll see a bunch of code which is already there. The part that interests us starts on line 169. Here we can define our own functions, which we then can call from the puzzles editor. Example: when the couch is clicked, we want the camera to fly to the living area, hide the categories, and show only the controls for the living room and the go back button. So in JavaScript, we're gonna create a function that sets the display of the categories and the controls of all other areas to none, and the display of the living room controls to block. Then in the puzzles editor, we're gonna call this function when the object is clicked and also add a tween camera block to move the camera. Next, we want the material to change when you click on an arrow button. In order to do that, we first need to define which material belongs to which object. We can do that by using lists. A list is always stored as a variable. So let's go to the variables category and create a new one. I'm first going to create a list of couch materials called something like couch materials. Then we can set a variable to a list of materials. If we want to add more than 3 materials to the list, we can add more elements by clicking the small blue icon and adding a few more items to the block. Now we can add the materials to the list using the materials selectors. You'll notice that there's only one material for the couch, even though we've created multiple ones. That's because Verge3D only exports materials that are actually used by an object in Blender. We can easily fix that by adding a plane for each unused material in the scene and adding the unused materials to them. If we then re-export the scene and reload the puzzles editor, the materials will show up. Now we'll need to figure out how to program it so that if we click the right arrow, the sofa will change to the next material on the list, and if we press the left arrow, it will change to the previous material. The solution I've come up is relatively simple. We first need to create a new variable. Let's call it couch material change and set it to a number which is divisible by the number of materials in the list. For instance, 500. Then, to make the material change when you click the right arrow, we need to add an event listener to the JavaScript which reacts when the arrow is clicked. When the event listener reacts, it calls a function called couchNext because we want the couch to switch to the next material in the list. The name obviously doesn't matter, but it makes sense to name it something meaningful. Then, when the couchNext function is called, a script in the puzzles editor gets triggered and adds 1 to the couch material change variable. Then, the next block takes the result of the remainder of couch material change divided by the length of couch materials, aka the number of couch materials, chooses the material in the list with the number of the result and applies it to the object. Then I did the same for the left button, but reduced the couch material change variable by 1 each time the function is called instead of adding 1. So that's pretty much it. The only thing left to do is maybe make some color adjustment, which you can do by using the post-processing block. Thanks a lot for watching. I really hope you've learned something in this tutorial. You can download the entire project on the blog post on cgbookcase.com. If you're watching on YouTube, there's a link to it in the video description. Also, if you want to buy Verge3D, you can get it 5% off using the coupon code below the video.